Hi, my name is Ricardo Ruiz, ID A01383658, and this is my first challenge. So basically, for this challenge, we're gonna divide it into 4 codes. Firstly, we're gonna describe our set point. So here we establish the node called set point, and we establish that the set point will be a sinusoidal graph given by the current time, and well, we're gonna publish this message. Then we're gonna have our PID controller. So basically, for my case, I used a PI, and well, here we're gonna just establish first the message, which will be control message, then our callbacks, which will be motor out and set point callback, and from here we're gonna establish in our main loop the KP and KI. In my case, KP of 1 and KI of 1.5 were the ones that gave me the best results. Here in the subscriber, we're subscribing to a previously made set point and to the motor output, which is given by the motor sim, but well, it will be in giving feedback to each other. So basically, it's receiving the feedback from the motor sim, and it is applying the equations with the PI to give it new inputs. So basically, we'll look at it further, but basically the PI is giving the input to the motor sim, and the motor sim is giving the output. So here we're subscribing to the output that is given by the motor sim and giving it back, basically. So for having bit feedback. Here are the equations that we're using. So we have that our error is equal to our set point minus the motor speed, and that our error is equal to the error plus the previously obtained error times dt. And we're just gonna use the equation of u of k, which will be kp times the error p plus ki times the error. And well, we're gonna publish this message, and this will be our control. So then we're gonna continue with our motor simulation. So here basically we're gonna also create a new message called motor message, and here we're gonna subscribe to the motor input, which I previously created in the PI, and here it's gonna publish the motor output. So it is giving feedback to each other, and it is applying the equations in a cycle and with the new data always. So here we're gonna have these two, which are the omega and the current dot. But basically here we're just gonna publish the omega, and here, well, we publish the omega, and finally we have our joints. So for this we're gonna declare the angle of the motor and well, the current times and all, and we're gonna declare the new message, which will be a joint state. So for this we're gonna have a header and well, a subjoint, which will be the world, obviously, and our wheel. So then we're gonna declare our motor callback, and from here we're just gonna first establish both joints position and velocity to 0, which then will be changed. But here basically we're gonna establish that our joint's velocity is equal to the motor velocity, and the position is equal to the pi of the angle. And well, that's basically the code. Here it is working. So basically here it is the code that I just showed you. So the set point, the PI controller, our motor sim, and the motor joint. So now I also created this launch file, which only establishes the basic configuration for the RVs and the whole URDF. And well, now we're gonna run it. Here we can see how the graph is making, getting the motor input, the motor output, and the set point. And over here we can see the RVs, how the wheel is rotating in a sinusoidal way.